In Module 2, Lesson 12, we're going to look at the division of integers. In class, you may have received related math facts, and each person needed to walk around the room and find those people who had facts that were related to theirs. For our example 1, I'll put in one set. We can see then the related math facts. 4 times 6 equals 24. 6 times 4 equals 24. 24 divided by 4 equals 6. And 24 divided by 6 equals 4. The next step would be to write 3 related multiplication facts. 2 of those facts need to have one factor that is negative, and one fact needs to have 2 factors that are both negative. So we see the related math facts. Negative 6 times 4 equals negative 24. Negative 4 times 6 equals negative 24. And negative 6 times negative 4 equals positive 24. Now we'll take those related math facts and we need to write 2 related division facts for each multiplication fact. And we can see all of the related division facts to our 3 facts on the right. In the next step then, we'll list the examples of division problems that produced a quotient that is a negative number. And there are 4 of those. From our list of the examples of the division problems that produced a quotient that is a negative number, remember a quotient is the answer to a division problem, we can then answer question B. If the quotient is a negative number, what must be true about the signs of the dividend and divisor? Dividend being the first number, the number you're dividing, divisor being the second number. When we look at the 2 numbers, we find negative, positive, negative, positive, positive, negative, positive, negative. So we can conclude that the signs of the dividend and divisor are not the same. They must be opposite. Continuing on, in question C, we're asked to list our examples of the division problems that produced a quotient that is a positive number. And we found 2 math facts in the box on the left. 24 divided by 4 equals 6. 24 divided by 6 equals 4. And 2 division facts in the circle on the right, in the bubble on the right. Negative 24 divided by negative 6 equals 4, and negative 24 divided by negative 4 equals 6. In question D, then, if the quotient is a positive number, what must be true about the signs of the dividend and divisor? So when we look at our dividends and divisors, we see a negative and a negative, negative and a negative, positive and positive, positive and positive. So we can say that the signs of the dividend and the divisor are the same in each case. At this point, we'll need to create rules for dividing 2 integers. So if we look at what we have already determined, we find that if the quotient is negative, the divisor and the dividend have opposite signs. And if the quotient is positive, the divisor and the dividend have the same signs. In exercise 2, we ask the basic question, is the quotient of 2 integers always an integer? And in class you would have time, and you should take time now to think about different examples that may prove or disprove your answer. So pause the video and take a few minutes to create a variety of quotients and see if you always get an integer. Then restart after you have taken some time. I've proven no, quotients of integers are not always integers. In my first example above, negative 24 divided by 6 yields an integer quotient of negative 4. However, when I switch the divisor and the dividend, the quotient divides a number with a smaller absolute value, that's 6, by a number with a greater absolute value, which is negative 24, making the quotient a rational number between negative 1 and 1. In other words, a number that is smaller than 1. And as you see the division written as a fraction, and then we simplify the fraction, we know that 1 divided by negative 4 is a negative answer, which is negative 1/4. So we can conclude that every quotient of two integers is always a rational number, but not always an integer. In exercise 3, we're given 3 representations and we're asked if the answers to these 3 quotients are the same or different. So we'll quickly divide. Negative 14 divided by 7 is negative 2. 14 divided by negative 7 is negative 2. And the opposite of the quotient of 14 and 7, 14 divided by 7, is 2, and the opposite of 2 is negative 2. So the quotients are the same. Our final exercise in this lesson is a page with integer division on it that you'll have to receive from your teacher. If you don't have that material, write yourself a bunch of math facts in division form and solve them and see what you get. Finally, complete the problem set for this lesson, and you'll be ready to move on.